Here we go. Find the equation of the line that is perpendicular to y is equal to 6 over 9x plus 3 and intersects it at x equals 3. All right, so we need to find a perpendicular line. Now, perpendicular and its friend, parallel, they basically relate, if you think about it, they relate to the slope of a line. So if I just give you a line here, and if I give you a parallel line, you're going to note that they have the same slope. You can tell just by looking at it. For the same run, they do the same rise. Now, parallel is also just a change of slope. Like if I give a line here, they both have the same y-intercept. The only thing that's different between the two equations of these lines is the m, the slope. So the question is, how do you find the m of a line that is parallel to a given line? You know that the only difference is the m. What is the relationship between the m's of two lines that are parallel to each other? Well, if you look at this line, let's say, well, let's just give ourselves a line like this. We'll give ourselves a line that has a slope of, let's see here, 4, 2, 1, 2, 3, 4, 1, 2. So this one has a slope of, I believe, about 1/2. That's freaking, just draw a straight line. No, that's even worse. God, drunken hand. Crouching tiger, drunken hand. There we go. It's not, it should pass through the origin, though. It doesn't matter. It doesn't matter. Okay, get back on track. So, you got this line, it's got a slope of 2. Tell me, guys, what is the equation of this line? Is y is equal to, did I say 2? I meant 1 over 2. 1 over 2x, right? X, the y-intercept is obviously at 0. You can tell just by looking at the line. It's clearly passing through 0. So anyways, so this is our equation of our line. Now, the perpendicular line, we can, even if we don't know it, we can eyeball it, right? Perpendicular means right angles. So we can draw a line. I'm going to puberty here. We can draw a line that's perpendicular. It'll look something like this. That was maybe even a little off. We could do it maybe something more like this. That looks about right? That looks about perpendicular. So, just by observing, we can tell some things about perpendicular lines. First of all, our original line here is increasing as you move right, y goes up. Positive m. Perpendicular line, as you go right, y goes down, negative m. So probably, we'll call our parallel one m prime is equal to negative m, maybe? But that's not right. Because if it was negative m, it would be something like, maybe like a this, right? It would have a more gradual slope because this is a half slope, right? So it would also have a gradual slope just going down, but it has a steep slope. And if you think about it, let's try a different line. As your primary line gets more gradual, your perpendicular is going to get more steep. So what we actually have here is a relationship m prime is equal to negative 1 over m. So we invert it. So for example, if our primary slope, if m is equal to 1 over 8, then m prime is going to be negative 8. Very steep slope. Very gradual slope, positive. Very steep slope, negative. So m is equal to negative 1 over m. M prime. That's the relationship. You either know that, or you look it up, or if you're a clever goose, you figure it out by observation. But anyways, given that information, let's solve the problem. So given that information, it's easy peasy. Find the equation the line is perpendicular to 6 over 9 plus x plus 3 and intersects at x equals 3. So slope is going to be, well, 6 over 9 is 2/3. So slope is going to be negative 3 over 2. Intersects at x equals 3. So we know that x equals 3 intersects our line. So we need to find the y point of intersection. So where is the y when x equals 3 in our original line? That's what we want to find out first. So let's put this on hold for a second here. We'll do y is equal to 6 over 9, well, 2/3. Let's not kid ourselves here. 2/3, 3 plus 3. Well, these cancel out, so it's just 2 plus 3. Y is equal to 5. Okay. And now we have the point of intersection, which is 3, 5. 3, 5. So we can plug that into here. 3, 5, B. So B is equal to 5. Well, what is this? 9, negative 9 over 2. All right. So 10 over 2 plus 9 over 2 is equal to B. Is equal to 19 over 2. So our equation of our line should be y is equal to negative 3 over 2x plus 19 over 2. It's not a beautiful number, but it's probably the correct answer. I don't know. I could be wrong. Let me know. The process is not wrong, however. If I've made a mistake in my calculations, be sure to let me know. But anyways, we're going to move on. All right, find the midpoint between negative 5, negative 3, and 0, 7. Okay, is that... No, that's not one of our points we had before. Negative 5, negative 3, and 0, 7. So, let's get a appropriate color. I'm feeling red. So, negative 5, negative 3, 0, 7. We want to find the midpoint between these 2 points. So that midpoint is going to be somewhere around, I don't know, maybe here. Just eyeballing it. I don't know where it's going to be. Now, the thing about the midpoint is if you break it down into its components, x and y, you will see it's actually quite straightforward. So, the midpoint, its x value, is going to be halfway between the x of the first point and the x of the second point. It's going to be the value which is halfway in between both of those. What is a value that is halfway in between two values? That's just the average of those two values, and we should know how to do the average. Average is just, v1 plus v2 over 2. So the mid x is the average between the x's of the 2 points, and the mid y is the average of the y's of the 2 points. So the midpoint is just going to be, say it with me, x1 plus x2 over 2, y1 plus y2 over 2. That's how you calculate the midpoint given any 2 points. So, what are our points here? Negative 5 plus 7. So, negative 5 plus, that's not right, negative 5 plus 0, there we go, over 2, which is going to be negative 2.5. And this one is negative 3 plus 7 over 2, which is equal to negative 2.5, and this is 4 over 2, 2. So, negative 2.52. And that indeed, if I just get a better color here, that indeed does look to be the actual midpoint between these two. So there you go. There's how you, it's a bad color. There's how you solve for the midpoint between 2 points. Very simple and quite useful. All right, next question. Find the perpendicular bisector line segment to make a perfect X with the line segment -5, -3, and 0, 7. So perfect X here means that both line segments are going to have the same length. And it's going to make a perfect X. So basically what we want to do is we want to make a line segment that crosses this line segment at its center and that is also perpendicular to the line segment. So luckily, we've already calculated the midpoint between these 2 points. That's right here. So this is where the other line is going to cross. Now we want to calculate the slope of this line here because that'll give us the slope of this boy here. How are we going to do that? Well, slope of this guy is going to be, let's see here, rise over run. So that is going to be 10, rising by 10, 10 over 5 equal to 2. So the slope is positive 2. So that means that the slope of our bisecting line is going to be -1/2. So m prime is -1/2. Now, we've got the -1/2. So that means that if we move over, well, first we can solve for the equation of the bisecting line. And that is going to be, well, this one here is 2. We have the 1 point on this line that we know is 2 -2.5. Slope is -1/2. So we go -1/2. -2.5 is -5/2 plus b. So we want to solve for b, and this is going to be 5/4. So we have 2 is 5/4. 2 is 8/4 minus 5/4 plus, no, is equal to b, is equal to 3/4. So b is 3/4. So that means that b should intersect with the y-axis right around here. And if we draw a liney-do here, we get something like that. Something like that. So there's our 2 lines, right? But we want the line segment that makes the perfect X. So the line segment here should be as long as this line segment here. So how do we do that? Well, there's a number of ways to do it, but the easiest way, by logic, is we can note that this triangle here is going to be an analog of this triangle here. So that means that this length here should be the same as this height here. So this height here is 5. So that means that this should go over 5, which should put it, well, 1, 2, 3, 4, 5. Should put it right here. So if we calculate the y at this x, we'll have the starting line segment point. And the same idea for here. We do that. Yeah, it'll be something like this. So should we go 5 over 1, 2, 3, 4, 5 here, calculated for here. So we calculate these two, and that'll give us the points of our x interbisector. Yeah, that's a good word. That's a word. So this, all we got to do then is just plug into the equation. So we plug into these equations here, and when we solve them, we get y1 is equal to 4.5 and y2 is equal to negative 0.5, which jives pretty much with our diagram here. This looks like about 4.5, and this looks like about, 0.5, give or take. So there you go. There is your line segment for your perfect X perpendicular bisector. By the way, the other way of solving this would be to set up an equation using a distance formula. So basically, a squared is equal to b squared plus c squared. Pythagorean theorem, you could set up a relationship to you could calculate this distance and then set up a relationship to use the distance equation to find the point that satisfies that distance on this line. But just doing it by inspection and similar triangles, logic of similar triangles, is easier. All right, let's continue on with the mathematical self-flagellation. It ain't so bad, is it? I hope it isn't so bad for you. Anyways, what are we at? We're at number 8. Find the closest point on the line to the point 5, 2. So, it's the same line that we've been using the whole time, right? It's this guy. And we want to find the closest point on this line to this point here, 5, 2. So, how would we do that? Well, let's, first of all, let's eyeball it for a second. Let's just take some ideas. So what about this point? It's got a distance of this much. All right. Well, we can even see that this is probably around -2. It's probably about 7, a little less than 7. Okay. What about this guy? You think this is closer or further than this? Yeah, it looks closer, right? This guy, hard to say, but I think this guy looks a little closer. What about this guy? See, now that's already looking further away. So, we can inspect a bunch of different points on this line and eyeball it, and what we'll notice is that the ones just around here are going to be the shortest. If you pull out your ruler and actually measure that shit, it's going to be this guy. Right around here. Now, what do we notice about the shortest line compared to these other guys? Well, we can notice that as this angle gets smaller and smaller, the point is getting further and further away. And the point at which it is the shortest, this angle here is about 90 degrees. What does that mean? That means that the line, let me just get a different color here. The line drawn through the point of intersection here and the actual point that we're testing, that's perpendicular to this line. So what we really want to do is we want to find the point of intersection between the original line and this perpendicular line that passes through the point of interest. Now, we can do that. I mean, we know how to find the slope of this line. It's just the negative inverse of the slope of this line. So we already have the slope. We also have one point on our new line. That's this point here. So if we have all that information, we can find the equation of this line. And once we have the equation of this line, we can find the point of intersection. So that's how you approach this problem. So we can see here, m prime, the slope of this line here, is going to be -3/2. We plug in this point into the equation, and we can solve for b prime, which is 19/2, or about 9.5. And if we look at our diagram, we can see, yeah, it's probably 9.5. I mean, my line wasn't drawn perfect, so I could see this being 9.5 easily. And now all we got to do is find the intersection between the original line and our new line. So we have our two equations now, our original one and our newly derived one. And all we got to do is basically we can plug the both equal to y. So we can plug this into the y here, set them equal to each other, and then we just solve for x. So here I multiply both sides by 2 to get rid of these guys, and then I move the constant over to the right and the x terms over to the left, factor out the coefficients of x, then I divide 13 by this amount, and the result is x is equal to 3. And if we look on the graph here, we can see, yeah, they probably do intersect at x equals 3. And if we were to plug x equals 3 into this equation here, well, that would just cancel out here, and you would get y is equal to 2 plus 3, which is 5, which is right here. So there you go. The point of intersection is 3, 5. That is 3, 5, and there's your problem solved. So yeah, the line passing through the closest point on a line to some other point, the line passing through that is going to be perpendicular to the original line. It's a good property to know, and it's pretty intuitive if you look at it.